Guys, in this video it's about integration by substitution method. Normally we will have two functions, fx and gx, or fx power n times gx. I have written gx is the derivative of fx. So we must have two functions with us, and then we will substitute using u. Okay, so there is a letter u we are going to use, and then we differentiate that to figure out what is our gx. So let u equals to fx, and then you differentiate it such that you may get more or less your second function, which is multiplied. Of course, sometimes we need to make some arrangements because of some constants. So if I write d over dx is f prime x, or it is gx actually, then make sure you change your du, because everything is going to change in u. In the beginning it's everything in x, but now we will integrate in terms of u. So if you assume u as fx and du as gx dx, so you have to replace your fx with u, okay, and gx times dx is du. So always remember, there should be one part in the function, in the integration, which you should have the derivative. So you integrate that like a basic rule, u square over 2 plus c, and then you replace back u. Let's take one example, because you have to understand with different examples. So the first example is x square plus, let's say, 3x, and we have second function as 2x plus 3. Now you can see very clearly this is a polynomial category. If your x square plus 3x is your fx, then 2x plus 3 is its derivative. So it's very simple. So this is the must condition. You should have both fx and f prime. So let u equals to x square plus 3x. Differentiate it. So du over dx is 2x plus 3. And then you rearrange. So you pass dx on other side, 2x plus 3 times dx. Now you have to replace these values in the original question. That's why we call it substitution method. We are going to substitute u and du in our integration. So the integration I equals to u times du. Now it's a simple function. We can integrate it, u square over 2 plus c, and you have to replace your u back. So x square plus 3x power 2, then divide by 2 plus c. Okay, that's it. That's how you have to do. Make sure you identify u and du. Let's take second example. So we have, for example, sine x power 3 times cos x dx. Now it's very clear to see that sine x is the function and cosine x is the derivative. So we are going to take u as sine x, okay, therefore du equals to cosine x into dx after rearranging. So you substitute these values in the original question, and you can rewrite it again like integration of u power 3 times du. Okay, then simple, u power 4 over 4 plus c, you plug that u back and you get your final result. So it's very easy. You have to just identify one function and its derivative. Let's take the third example. Integration of, I'm gonna take with the fractions. So let's say 1 plus, don't take 1 plus, let's take 1 minus. So 1 minus sine x divided by x plus cos x to the power 3. Now it's a different one, okay? We are taking in the denominator something and with some powers. So you always remember, you can rewrite your function in two parts, like 1 over x plus cos x power 3 times 1 minus sine x dx. Okay, now this will help you to identify which one is the function and which one is the derivative. So you can see x plus cos x can be u because it has a power. Okay, so u is x plus cos x, and the derivative is 1 minus sin x. Oh, I'm writing wrong, need to change it. It's x plus cos x. So the derivative is 1 minus sin x. The derivative of cos is negative. Okay, negative sin x. So now you substitute these values, 1 minus sin x dx as du, and x plus cos x is u. So 1 over u power 3 times du. Remember, bring the power up and then you apply the rule. U power negative 3 plus 1 is negative 2 over negative 2 plus c. It should not be plus 1, it should be plus c. And then you substitute your u back. Keep trying these problems. Thank you.